Hi everyone, my name is Darria Carter, and today I'll be talking about corrosion. I've decided to present on corrosion because I took a corrosion science and engineering course a few semesters ago and I really enjoyed the subject. It's a pretty broad subject, but today I'm just going to focus on the main points. Here's an outline of what I'll be presenting on today. I will start off with an introduction to corrosion, then I'll talk about the common types of corrosion, how corrosion is related to thermodynamics, some common corrosion issues that are found in industry, and then I'll wrap it up with the conclusion. So what is corrosion? Corrosion is defined as a degradation of metals due to its environment. Metals are typically not found in their pure form. They must be extracted from ores such as sulfides and oxides, and once they're extracted, they're at a higher energy state. And materials in nature typically want to be at lower energy states, or the lowest energy state possible. In order to do this, corrosion will take place. There are four components necessary for corrosion to occur. First, you must have an anodic reaction, which is where the electrons leave the site where corrosion takes place. There's a cathodic reaction, which is a site that accepts the electrons from the anodic site. There must be a path of contact between the anode and the cathode. And finally, there must be electrolytes present, which is typically water. Here are four examples of different types of corrosion. In the top left corner, you see uniform attack corrosion, which is where the metal is attacked evenly over the surface. At the top right, you see stress corrosion cracking, which is where a combination of applied stress and a chemical environment causes cracking in the metal. At the bottom left, you see pitting, which is where the metal is attacked at certain fixed sites. And at the bottom right, you see galvanic corrosion, which is where one metal corrodes preferentially over another. Now I'm going to talk about how corrosion is related to thermodynamics. One important concept is Gibbs-free energy, which determines if a reaction can take place. Gibbs-free energy as it relates to corrosion represents the free energy change for an electrochemical process. It's equal to N times F times E, where N is the number of electrons transferred, F is Faraday's constant, and E is the electric potential difference, which is a value that can be found in the EMF series. Nernst's equation tells us how the cell potential varies with certain conditions. It allows us to relate the cell potential at any state to the cell potential at a standard state and to the products and reactants of the electrochemical reaction. Then there's the Porbet diagram, which summarizes corrosion thermodynamic information using a potential versus pH diagram, as shown in the bottom right. If we know the electric potential and the pH of a system, then we can predict if corrosion will occur based on the region you are in the diagram. If you're in the corrosion region, that means that corrosion is active and will happen. Passivation means that passive layers that inhibit the corrosion process are being formed, and immunity means that no corrosion will take place. Now I'm going to talk about corrosion in a few industries. You will see it in the oil and gas industry, in pipelines and drilling equipment. You will also see it in the automotive industry, inside of engines. You'll see it on exhaust systems as well as paint coatings. And you will see it in electronics. You'll see it on computers. You'll see it on integrated circuits as well as microchips. Some other industries that corrosion takes place in is the food and beverage industry, nuclear industry, as well as aircraft. In conclusion, once again, corrosion is defined as the degradation of a metal that's caused by its environment. There are four things that must be present in order for corrosion to take place. That's the anodic reaction, the cathodic reaction, a metallic path of contact, and the presence of an electrolyte. There are several types of corrosion. I talked about four. Those were uniform attack corrosion, stress corrosion cracking, galvanic corrosion, and pitting. There's a relationship between corrosion and thermodynamics. I talked about the Gibbs-free energy equation, the Nernst equation, as well as the Porbet diagrams. And again, corrosion is a problem in many industries, unfortunately. That concludes my presentation. Thank you all for your time. I hope you all learned something, and have a great day.